Hello everyone, welcome to my channel Chemistry is Fun. Today we will be dealing with a portion of chemical bonding chapter which states the conditions for forming electrovalent bond. In our previous video, I have discussed about the electrovalent bond, how is it formed and its definition. So electrovalent bond is formed by electrostatic force of attraction between oppositely charged ions, which are namely cations, which are positively charged, and anions. Cations and anions. Cations like Na plus, Mg2 plus, anions like Cl minus, chloride. So when the electrovalent bond formation takes place, certain conditions are to be fulfilled. The first condition being number of valence electrons. Now see, in some atom there may be 1 or 2 or 3 electrons in the valence shell. Valence shell is the outermost shell which usually participates in bonding. So if there are either 1, 2 or 3 electrons in the valence shell, that atom can tend to lose the electrons. It can lose the electrons. Up to 3 electrons can be lost. For example, in case of aluminium, it forms Al3 plus cation by losing 3 electrons. Whereas among the nonmetals, we find that there are some atoms which have 5, 6 or 7 valence electrons. It is not possible to lose these many electrons because it will make the ion unstable after losing so many electrons. Therefore, in this situation, which are mostly nonmetals, they tend to gain electrons. As we have seen in case of chlorine, it will gain 1 electron to form chloride anion. These nonmetals are mostly electronegative. They can easily gain electrons to form the anions like chloride anion, and by doing so, its octet gets completed. So, we can conclude that any atom which is having 1, 2 or 3 valence electrons, they will be forming cation as we have seen in case of Al3 plus, otherwise Na plus, and the atom which has either 5, 6 or 7 electrons can form anion as we have seen in Cl minus, chloride anion. The second important factor which decides the formation of the electrovalent bond or ionic bond is the difference in electronegativity. The nonmetals are mostly highly electronegative. The nonmetals are highly electronegative. The metals are electropositive in nature. So definitely there will be a difference in the electronegativity between the atoms that can help in the formation of the ionic bond. Metals like sodium, they are electropositive, which are found in the left side of the periodic table. Alkali metals, alkaline earth metals, they are all electropositive in nature, whereas nonmetals are electronegative in nature. So the difference in electronegativity should be quite high to facilitate the formation of the ionic bond. This difference of electronegativity should be at least of the value of 2. For example, if we see the electronegativity of sodium is 0.9, that of fluorine is 4. So here the difference being 3.1. So the sodium fluoride salt, that is the ionic compound, can be easily formed because the difference of electronegativity is quite high. Third important factor is that overall when this full process takes place, there should be a decrease in the energy because fall of energy facilitates stability. So we find that whenever a metal has to form cation, there is some energy required for removing the electron so that the cation is formed. This energy is the ionization energy. Lower the ionization energy, very easily the cation can be formed. So the lower value of ionization energy will help to form cation easily and thus help in ionic bond formation. Whenever any electron is added to any atom, neutral gaseous atom, like in chlorine we add an electron, it becomes a chloride anion, that time some amount of energy will be given out. This amount of energy given out is called the electron affinity. So when the electron affinity value is high, the anion formation takes place very easily. Therefore, it is favorable to have high electron affinity to facilitate ionic bond formation. Whenever the positive and the negative ions come closer to each other, and with the help of electrostatic force of attraction they form the ionic bond, at that time some energy will be released, that is the lattice energy. This lattice energy helps to condense the ions into a crystal. So whenever 1 mole of compound is formed, the total amount of energy given out during lattice formation is the lattice energy. Higher the value of lattice energy, ionic bond formation will be greater, facilitated, or we can say that it has a greater chance. So we can conclude that ionic bond is electrostatic. That is, the cation and the anion is held together by electrostatic force of attraction. Cations like Na plus, Mg2 plus, anions like Cl minus, they are held by electrostatic force of attraction. Another important factor is low ionization potential, high electron affinity. They both help to form the ionic bond. The lattice energy should be high enough. All these factors help in formation of ionic bond. Now, since the ionic bond involves the ions, we should also have a look at the types of ions. So first is a type of ion with inert gas configuration. Inert gas configuration can be of the type NS2 or NS2-NP6. Hydrogen, as we know, if it gains one electron, it gains 1s2 configuration. Similarly, lithium cation, when lithium atom loses electron Li plus, it is also of the type NS2. Whereas Na plus and Cl minus are of the type NS2-NP6. This is the case where we have inert gas configuration. Next, we have some ions with pseudo-inert gas configuration. Pseudo-inert gas configurations are exhibited by d block elements like zinc. When zinc loses the 4s electrons, it forms a zinc cation Zn2+. Its configuration is 3s2, 3p6, 3d10. This is pseudo-inert gas configuration. This is another type. Some ions like Fe3+ have exceptional configuration. That is, they have half-filled d orbitals. Maximum capacity of d orbitals is 10. So it is having 5 electrons, so it is half-filled. Half-filled orbitals are also extra stable. So Fe3+ with configuration 3s2, 3p6, 3d5 also gains stability. So this is an exceptional configuration. There are some higher ions which having NS2 configuration are also stable, like Sn2+, Pb2+. They are having NS2 configuration, but still they are stable ions. So these are certain examples of some ions we have seen today. So this is a little addition to what I have dealt with in my previous video of ionic bond. Hope you could understand the video today. Please subscribe to my channel. Thanks for watching. Thank you.